Anyway, so this is kind of a first step with repulsion bounce. Let's go ahead and remove that. Let's take a look again. We're set up right now to actually have them attract toward each other. Let's go ahead and switch this. We're going to set it back to its default values, and we're going to enable the drag, and now we're going to enable the shooter. Shooter just basically, this is kind of a modified dynamic set. We take a node, this point helper, and we get his position and his alignment, figure out his y direction. We're going to born a particle from that position in that y direction, which is this way. And he's got a bunch of speed. Right now we're just using pistol shot, but in the future we'd probably want to use multiple particles per second. And we want them to have a little bit of direction variation, so they're not always going the exact same way. But here's a problem. We've got all these particles coming out, and we want all of our targets are on this flat plane. So we definitely want these red particles to always be in the XY plane and not have any Z component to their velocity. So what we have to do is we have to modify their velocity at birth and assign them a new velocity that does not have any Z value. The way we're going to do that is we're going to use this born particle output, use a particle data helper, which is right there. And what this does is it takes a particle and is going to output any of this information about him. In this case we're going to use his velocity. Take that velocity into an expression helper where we use the original x and y velocity, but we set the z component to 0. And that'll remove that height ability, so he will not be going high or low here. He'll just go straight out in that xy plane. And then we reassign that new velocity vector back with the particle data operator, which is over here. And this is used to assign actual parameters to particles. Okay, so that's shooter. And let's go ahead and take a look. PPass AB, we're going to set this up now to be an interaction between red and blue. And then let's just go ahead and see what happens. Let's go ahead and hit play. I'm not sure if the screen capture software is capturing this, so we're just going to scrub. We can see that red particle go in there and knock a bunch of those blue particles around. We can see some of the blue particles spinning, kind of rotating around. Let's go ahead and take a look. We'll set the repulsion really high, and this should give us a stronger. Yeah, you can kind of see them push away more. Let's actually zoom out up here, and we'll maybe be able to see how far they go. Let's go ahead and take a look at the bounce. If we set maybe the bounce to 2, it should add energy during their interaction and make them go much faster in the way they're going. There you can see that those blue ones really take off the screen. Okay, we'll go ahead and set that back there. But then bounce elasticity. Bounce elasticity, is set to 0.5 right now, so we get this kind of reaction. And remember, this handles energy loss during the interaction. So if we go ahead and set this to 0, then we get a very different kind of outcome. And you can see that these blue particles are not hitting each other. That might be a problem, so let's go ahead and create another dynamic set. We'll go up to this top level. We've got this repulsion bounce here. Let's create another one. Let's name this repulsion bounce blue. And put that drag underneath there. And in this repulsion bounce blue, what we want is we want to handle interaction between blue and blue particles. And in this case, we're going to set that distance to 10. Let's just drop a sphere in here to see what kind of distances we're dealing with. So this is about a distance of 10 here. The radius is 10. So we'll go ahead and just use that for now. So this will actually, and let's set that to 0.5 on this bounce elasticity. So now the red particle will hit the blue, and then the blue are going to bounce off of each other. And so we get a very different kind of reaction there. Now let's go ahead and set shooter to emit multiple particles per second. And we're going to set this viewport here to be in the side view so that we can see that these red particles are always only going in the XY plane. Let's set this up, and wow, that rate's a little too fast. Let's go ahead and drop this down. Boom. knocking them in there. Now we might want the drag a little bit higher, so let's go ahead and set that friction to a value of 1. Maybe even higher. Let's try 2. And we can see definitely up here that we're only emitting those red particles in the XY plane. And okay, so let's also take a look at the mass component here. We've got a mass of for the shooter particles, the red particles, as 5. If we just set that to 1, we're going to get the red particles really aren't going to affect the blue quite so heavily. Let's do this. We want to actually take a look at one of the other settings. Let's set the mass back to 5, and we'll see kind of what happens a few frames. Kind of the general feel of the simulation here. And then what we want to do is come into RepulsionBounce, and we're going to set this mass multiplier. Let's go ahead and just set it to 10. And what this will do, remember, is it will look at the two masses. Nope, not that one. I'm going to modify the wrong RepulsionBounce. We want this mass here to be 10. So this is the interaction between the red and the blue particles. And the red particles now are still 5, and the blue particles still 1. But now what we're going to do is we're going to have their mass difference be more pronounced by a factor of 10. So now you can really see there's a huge difference. Those red particles are just plowing through there. If we go ahead and drop this down, maybe we'll set it to 3, we'll see still some, but not so much. And then we'll also go ahead and make this mass, say 0.1, and this should reduce quite a bit. Yep. Okay, so we took a look at how to use RepulsionBounce as a keep apart as well as an attract force. Most importantly for attract, remember to lower your bounce energy multiplier here. And we also took a look at how to use PPAS AB with RepulsionBounce to go ahead and kind of simulate collisions here. Okay, we'll go ahead and save this file and we'll move on.